Yeah, everybody, this is 6.2 on quadratic functions, and we're talking about parabolas. We have to remember the transformations that we learned in module 2. Okay, right before module 2, we learned about transformations and what if we add or subtract, what happens, if we stretch or compress, what happens, or if we reflect it, what happens to the function. Okay, so remember this chart that we had. So you guys should have this in your notes. I'm just gonna move right along. Parent functions. Remember the definition of parent functions are functions without any transformations. So the most basic function, right? So a parent function today, what we're dealing with in module 6 is the function of x squared. Okay, and in class today, we are gonna cover what x squared is. And remember the parent points are going to be that -2, 4, 1, 1, 0, 0, 1, 1, and 2, 4. Okay, so this parent function and these parent points are always going to be on it. Okay, this is what represents your parent function, and this is the points that you're going to graph to graph your parent function. Okay, so the parent graph here. Okay, so I have 0, 0. I have 0, 0 here. Remember that point is called the vertex. Okay, that's where it's going to change from increasing to decreasing or decreasing to increasing. All right, and then we're going to move it up. Yeah, so it looks like that, right? Where it's -1, 1, -2, and then 4, and then 1, 1, 1, and 2, 4. So that's your parent function. You guys see this green dotted line through your y-axis? That is called your axis of symmetry. Okay, and with your axis of symmetry, it's the vertical line that cuts the parabola into 2 even pieces. All right, so you can see that this vertical line here, the green vertical line, the dotted line, the y-axis, it acts like a mirror in terms of your parabola. So I erase the right-hand side, but then if I go ahead and add the right-hand side, this side should be the mirror image of your left-hand side if you fold it along your axis of symmetry. All right, your axis of symmetry is going to be x. The equation of it is going to be x equals 0. And now the only thing that moves this, only thing that changes this, only changes when you shift left or right. Okay? The vertex only changes with shifts. Up, down, left, right. All right? And at this point here, one cool thing about this point here, the vertex will always be a part of your axis of symmetry. Right? So then if this moves to the left to that point, then my axis of symmetry would be here. Okay? So just remember that, and it only changes with shift. So I'm going to go ahead and talk about the general form of a parabola. All right, so the general form of a parabola is f of x equals a times x minus h quantity squared plus k. Okay, so notice that my a value here, it's on the outside, and we're multiplying my parent function. So that's going to be a vertical stretch. or compressed depending on what A is. Okay. So if A is greater than 1, it's a stretch. Okay. If the absolute value of A is between 0 and 1, that's going to be a compress. Okay. And I should put here as well absolute value. If the absolute value of A is greater than 1, it's a stretch. And if it's between 0 and 1, absolute value of A, then it's a compress. All right. And you guys we'll figure that out later as we do examples. And your H and your K class, this value and this value, that is your vertex. Okay, so then if it's in this form, you automatically know where your vertex is. And a little thing, plus and the minus, right? It's minus H and plus K. Notice that's my shifts in transformation, right? We're going to shift it left or right, H units, or up or down, K units, right? It's my vertical or my horizontal shift, right? And remember that my vertex started off here at 0, 0. Okay, so if my vertex starts off at 0, 0, H and K are my shifts. Okay, and that's also my vertex. So there's a cool connection. Hopefully you guys made. All right, so I'm going to go ahead and graph these two examples, and then that'll be the video. Okay, so we're going to graph this. So remember that my parent function is f of x equals x squared, right? And we're going to go through the steps again. Okay, so from here, I know that this 2 is different. I know that this 2 is different. And I know that this 5 is different, right? So then they all represent transformations. Now, remember back in our transformation unit, our lesson, this 2 here, right? We are multiplying the function by 2. When we're multiplying, it's a stretch or compress. Since it's on the outside, it's a vertical stretch or compress. So this is a vertical stretch because 2 is greater than 1. Right? BAFO, meaning by a factor of 2. Okay. What does this blue do? Blue 2 do? I'll give you guys a second to think about that. And now hopefully you guys said, I'm going to move this to shift. I'll write it out. Shift 2 units to the right. Okay. And check out what this 5 does. Okay. What does that 5 do? Hopefully, again, you said shift 5 units to the up. Okay, so they are my transformations. These are all my transformations. Okay. So now we can graph this one of 2 ways. I'm going to graph it both. Okay, first off, what we can do is graph it using graph paper. Just graph it, right? So my parent point, remember, is 0, 0, negative 1, 1, 1, 1. Right? Let me put this like that. Okay. Negative 2, 4. So 1, 2, 3, 4. And then 2, 1, 2, 3, 4. 2, 4, right? So then here is, oops, here's my parent function. So in black, it's y equals x squared. Now remember when we graphed it in module 2, we stretched it before we put our shifts last. So we're going to vertically stretch it by a factor of 2. So since we're vertically stretching this, we're stretching it up and down, or up in this case because it's a stretch. So all of my y values, 4 and 1 in this case, is going to be multiplied by 2. Okay, so 4 times 2 is 8. So 4, 5, 6, 7, 8. So this point here becomes all the way up to there. Those 2 points. Okay. 1 times 2 is 2. So this point here and this point here becomes these 2 points. Okay. And then 0 times 2 is still 0. So my vertex does not change. Remember, it only changes with shifts. Only changes with shifts. So that would stay the same. Okay. And we'll take every point, move it over to the right 2 and up 5. So if I take it to the right 2 first, 1, 2, my vertex is here. 1, 2, 1, 2, 1, 2, 1, 2. So you see how that. So actually going back, my purple line, my purple parabola would be y equals 2x squared. Okay. My blue parabola right here and right here, that becomes y equals 2 times x minus 2 squared, right? And then if I move all the points up 5, 1, 2, 3, 4, 5, my vertex is there. 1, 2, 3, 4, 5. That's that point. 1, 2, 3, 4, 5. That's that point. And then the other 2 I'm not going to draw. So that's going to be out of the graph. So there's my parabola. And my red one here, that's my final graph. That's my transformed graph. Okay. The other way I see students do it, and I teach, okay, y equals x squared, is use the parent points. If we use the parent points, class, then it becomes more consistent, and you kind of know what you're doing. So my first transformation is we're vertically stretching it by a factor of 2. So it's y equals 2x squared, right? And that's my x, and that's my y. Okay, so here, if I vertically stretch it by a factor of 2, that means my y value is going to be multiplied by 2. Okay, so all we're doing, we're keeping my x value as is. Okay, -2, -1, 0, 1, 2, -2, -1, 0, 1, 2, right? And my y value, we're multiplying it by 2. So 4 times 2 is 8. 1 times 2 is 2. 0 times 2 is 0. 1 times 2 is 2. 2 times 2 is, oh wait, why is that 2? 4 times 2 is 8. Okay? And for the shifts, I'm going to do it together. Meaning x and y. The 2 shifts here, I'm going to do them all together in 1. Okay? So I'm going to move it to the right 2, up 5. If I move my x value, if I move my graph to the right 2 units, so I move my graph to to the right 2 units, right? My x value grew by 2. So that's x plus 2. And then my y value being up 5, that's just y plus 5. So negative 2 plus 2 is 0. Negative 1 plus 2 is 1. 0 plus 2 is 2. 1 plus 2 is 3. 2 plus 2 is 4. Plus 5. 8 plus 5 is 13. 2 plus 5 is 7. 0 plus 5 is 5. 2 plus 5 is 7. 8 plus 5 is 13. Now notice that I got these points. I didn't go back to the original, and I transferred it. I transferred this over, use my purple point as my function, right? And then I shifted it to that. So on an exam, what I'm going to ask you, if you guys do this, right, is always, 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 what we're going to do always, always and forever, is what we're going to do is we are going to graph first the parent function. Okay, always. That's off. We're going to graph the parent function. In blue, I'm going to graph 0, 0, negative 1, 1, 1, 1, 2, 4, and negative 2, 4. Okay. Okay. Try our best to make a good looking parabola. All right. And then you guys can just jump over to the green. 0, 13. So it's 1, 2, 3, 4, 5, 6, 7, 8, 9, 10, 11, 12, 13. So that's that. 1, 7. So 1, 1, 2, 3, 4, 5, 6, 7. And 0, 2, 5. 1, 2, 1, 2, 3, 4, 5. And then look. Okay, that's my left hand side, right? Right in the middle, through my vertex, up a vertical line. That's my axis of symmetry. So since this point here is 1 unit away, go 1 unit away again, and you get this point. Okay? This point here is 1, 2 units away. So go 1, 2 units away. And that point there, this is my problem here. You guys see how we use the axis of symmetry? I missed that. Oops. We use the axis of symmetry as well, okay, to help us graph. So that equation is x equals 2, and that's my parabola. My axis of symmetry will always be x equals h. How many ever units I move it to the left or to the right, that's my h value. Okay? All right. Next one is that one there. Okay. So again, from my parent function, I know I have that, I know I have that, and I know I have that, right, as my transformation. My parent function is f of x equals x squared. In blue, the 1/2, that's a vertical compress by a factor of 2. Okay. I'm going to actually do the shifts all together. So the -3 means I'm going to move it to the left. Think opposite to the right 3. And the -4, I'm going to move it down 4 units. All right, let me check something really quick. Yeah. Okay. Right. So these are my transformations here. All right. I'm not going to do both of it. I'm just going to start off with my parent points. Remember my parent points. We have my x and my y value. And we have -2, 4, 1, 1, 0, 0, -1, 1, 1, 1, and 2, 4. And then if I vertically compress it by a factor of 1/2, that means that's going to be y equals 1/2 x squared, right? So my x and my y value, -2, comma 2, -1, comma 1/2. I'm going to divide my y value by a half to 2. All right. And now here, we're going to move it to the right 3, down 4. If I move something to the right, that means that my x value is going to be adding 3, a value of 3. If I move it down 4 units, my y value is subtracted by 4. Okay, so -2 plus 3 is 1, and then 2, and then 3, and then 4, and then 5. 2 minus 4 is -2. 1/2 minus 4 is -7/2. 0 minus 4 is -4. 1/2 minus 4 is -7/2. 2 minus 4 is -2. So here are my finished product points. Right? This would represent y equals 1/2 x minus 3 quantity squared minus 4. All right. So I have my graph paper right here, all the way down to the bottom. I'm going to move it up a little bit. There is my function here, right? So first step would be to graph your parent function. And with your parent function, the more you do it, you know the point already, right? So you don't have to draw the parabola. You can if you want to, but I won't require it on your parent function. It's just those points that I'm interested in. And if I go straight to the or the purple points, -3 or +3, comma 4, +3, comma -4, right? There's my vertex. So I know that my axis symmetry will be right here. Okay. Don't forget the lines on the top and the bottom. Now that's -3, 4, 1, comma -2 is right here. So since that point is 1, 2 units away, Go 2 units away again. Okay. All right. We got that. Okay, and then we got 1, 2, right? So my next point, we're gonna graph 1 comma -2. Oh no, we already did that. 2 comma, what is that? 3 and 1/2 negative. 3 and 1/2. So it's 2 comma 1, 2, 3 and 1/2. Since that guy is 1, this guy is another 1. Okay, so then you can draw your parabola. Notice that it's a little scattered. Okay. All right, cool. So there is my lesson for today. All right, thank you, and I will see you on the next one.